Hello friend, in this video I will discuss with you and sharing the experience of pump down, pump out of refrigerant because I am working on large plant, bigger plant like capacity 6,000, 10,000, 20 and 30,000. This it is tons, 20,000, 30,000 tons of plant I am working. So I am giving my experience and knowledge sharing with you same capacity. Not small chiller, air cooled chiller. Small air cooled chiller you can pump out by portable unit and small cylinder, 65 kg cylinder you can pump out. But I am talking about this 1500 ton, 200 2,000 kg of refrigerant. When I appointed in one plant, it is 5 carrier 17 FA chiller. One chiller has 6,200 kg R12. And now R12 to bend, I will talking about this 94, 95. Then R12 is not bend. So one chiller has 6,200 kg of R12. So 5 chiller is 31,000 kg entire plant. And because of this risk, suppose any case it is in the plant room, any leak come, big leak comes or sophisticated leak come, and this air will cut off. Company provide the breathing apparatus with fresh air, breathing apparatus in case of emergency. Plant have any big leak, so we can wear this breathing apparatus, fresh air, oxygen breathing apparatus, and go to plant room for emergency. It's a very big plant. So therefore I will talking about larger plant and huge quantity of refrigerant handling. This is a 19A pump out unit carrier. It is standard you can find on centrifugal chillers. So pump out and pump down and pump out procedure is totally different. As per my knowledge, some chiller have programmed. They using word of pump down. Pump down means when they shut down, then they have to pump down. This is normal procedure. They have to close the solenoid, pump down, and can shut down. This is normal. This use shut down. But sometimes you have to pump down. You can use in the chiller to manually transfer the refrigerant from one vessel to another vessel because big quantity. So in centrifugal chiller, you have to pump down also and pump out also. Pump out means you have to remove all refrigerant from the chiller, and pump down means you can transfer any vessel, cooler or condenser, to store the entire refrigerant and work other area. Evaporator work you can transfer to condenser. In condenser work you have transfer to evaporator. Any one place you have to transfer it in the system, in the chiller. It is called pump down. And if you want to remove entire refrigerant from the system and put on zero pressure, you have to remove refrigerant, and it's called pump out, means remove all refrigerant. The main procedure before starting pump down, pump out, you should be circulate condenser and chill water pump in the chiller. If you not circulate this water circulation of condenser and chill water in the evaporator and condenser, what happens when the removing of refrigerant with pump down or pump out, one vessel is come to low pressure, low temperature and low pressure. Pump out suck the refrigerant and remove the refrigerant. In this procedure, in the cooler or evaporator, temperature go down, and you have not run the chill water or condenser water. The water in the tube get freeze up, then freeze up and crack the tube or leak the tube. This makes big problem to your work. So first lesson of the centrifugal chiller or large quantity chiller, any chiller which have large quantity of refrigerant, if you pump down or pump out, you should be circulate continue water in the chill water line tube and condenser water line tube. Do not start pump down or pump out until water circulation completed. If water circulation is not completed, don't start. This is the first lesson in the centrifugal chiller. Second thing, you in pump down procedure, you should have isolation valve, liquid line and upper line. Both valve have in good condition and hold the refrigerant. If you want to transfer cooler or condenser, if valve is not holding and leaking, so no use to pump down. You not possible to pump down the refrigerant. So you have no choice but to remove all refrigerant from the system. So we have to do pump down. What we do that we have to keep open the liquid line valve from condenser to cooler, and upper valve, discharge valve, which is isolation valve, we have close. Sometime in the plant room they have already piping for pump down. A unit have pump down unit, centrifugal. Sometimes this don't have the pump down unit. Some plant I see each chiller have their own pump down unit with piping and everything. Sometimes I see that plant not have, each chiller don't have the pump down, but plant must need one storage capacity, storage tank with pump down unit. Carrier have this full set of pump down storage tank and pump down unit. So is in the plant one or two storage tank with pump down unit must be there. In case of you want to remove refrigerant from chiller, 10, 15, 20 chiller have, you have to one or two, minimum one, but some plant have two storage facilities, storage tank with pump down unit. And some plant I see the permanent piping, and some plant have this flexible. They can make local made flexible pipe, roll and secured. Sometime when you want to use, to it is reach to all chiller. Up to last chiller it will reach. Two line need, one for section, one for discharge. So you can change this one. So two flexible hose, half inch height, need to all chiller, reach to all chiller. You need. So if you pump down or pump out, you need to make open the liquid line, continue upper side, you can close the valve and make suppose you want to store in the condenser, you put this one discharge line, compressor pump out, compressor discharge line to evaporator, and suction line you make in the condenser, and pump out unit run. It will give the pressure hot gas to evaporator and take refrigerant, suction refrigerant to from condenser. So what happens when the pushing of hot gas in the evaporator, they will push. But also this condenser of taking refrigerant, making low pressure. So in pressure difference, liquid will be pressed and transferred to in the condenser. When you think all refrigerant, liquid refrigerant transferred in the condenser, you close the liquid light valve. Now both is isolated. Condenser also close upper valve, and downward both isolation valve close. So condenser is separate and cooler is separate. Now you have this, see the valves, this is 4 valve. Alternatively, oppositely they will change. So what we will do, you will do that, you will reverse the cycle of refrigerant. You take the refrigerant suction line and discharge in the condenser. So what happens, now before is taking from condenser, now is taking from evaporator. Vapor will taking, suction will taking from evaporator and give discharge into condenser. So remember that When you put the reverse cycle, now discharge head hot gas is going to condenser, taking the evaporator section from evaporator and discharge going to condenser. What you have to remember that you open this uh, condenser water line, they write here, two valve there. You open the water flow valve. But I say this is not condenser water. We will recommend for chill water line. Chill water is available in the plant room. So is cool water is this water valve before close give to hot gas into condenser. Now you open this valve. So what happens? Liquid gas will convert into liquid and give go into the condenser. So slowly they will take all vapor and pressure will you show in the gauge, pressure will down from condenser cooler evaporator. When it's come to before zero, we check by hand some little pressure to 1 or 2 psi. You close the pump out system, close all valve. This is the procedure to pump down or pump out. In other case, must chill water and condenser water both are running. In other case, you want to pump out the system and remove all refrigerant from the sticker. Same the chiller, all chiller have liquid line. So connect this adapter and liquid line to cooler and connect the bottom line or the storage tank. Storage tank also have compressor and make section of storage tank, compressor start and section of storage tank and give discharge up in the this one unit. So unit condenser pressurized unit of from upper side and hot gas going to the unit and this vapor taking suction taking from the storage tank. So storage tank have low pressure and then this pressure is high in the chiller. They will push, just pushing the liquid. So all liquid push and come into a storage tank. Same like this pump down. After you think all refrigerant is liquid refrigerant out from the chiller, you have to change the cycle. What cycle? You take close the liquid line valve and this one change the suction valve. This take only one suction valve and discharge in the storage tank. Now we take suction from upper side and make liquid. Open this liquid pump down liquid line valve, chill water. Then the liquid will convert, gas will convert into liquid and throw in the storage tank. Downward liquid line valve is closed, so it will not go past. Only suction line need. No need that two lines. Before pushing the refrigerant, both line need suction and discharge. When the transferring of vapor, you close the liquid line downward. Only suction line need. Suction line will take refrigerant from upper side and remove vapor from the system, convert into liquid and throw in the storage tank. The storage tank maybe not have side glass, I don't see, but it have electronic liquid level control switch. Level control switch will monitor that a safe level of liquid coming. If liquid touch to the switch will shut down the pump out unit. So it is protection is there that you cannot see, but you cannot fool. This protection switch, level switch will cut off the unit. Same way you transfer large vapor, then pressure is down to zero. You stop the pump out unit and remove this line. So this is procedure of handling refrigerant, and this very large quantity I doing, so I will tell you this my experience. Maybe in future you have some big plant. So one small chiller 19XR and screw chiller XA is small refrigerant in front of us because we are handling big refrigerant is nothing because So 4-5 cylinder or 65 kg cylinder portable unit my other team are doing, but because handling the large quantity, so I give you my experience. What is the main point? Keep running water in condenser and in cooler. Otherwise, freeze up occur in the tubes if you not run. Water is there in the pipeline. If the water not run, remaining water will freeze up and make crack or leakage is the problem. So keep it running until pump out procedure. Press the unit which you want to remove the gas. This pressure unit and suction the unit we want to transfer. So low pressure will push the refrigerant, liquid refrigerant to where you want to transfer and push all liquid and remove. Then after that when liquid push out, then remove the this one vapor. So reverse the cycle and vapor how you remove? You go to vapor take suction line take from the system, go in the pump out unit and pump out unit discharge its own evaporator, convert into liquid and transfer in the storage tank. I think maybe if somebody can understand help this one because this is a very big plant and big refrigerant, so we're doing like this. Thank you for watching for this video. Thank you.